Hello, today I'm going to talk about orthographic projection. I'm just going to go through the basic properties of it and what it entails. So firstly, what it is it represents three-dimensional objects into two dimensions. So basically, once you have an object and you're looking at it in an isometric view on a plane's reference, which I'll go through later on, you'll see it from two views and it'll be either the front or the top view. So also it's a form of parallel projection. So that means when it's on a plane's reference and the object is on either the first or the third quadrant, which I'll also go through later on, all the lines will project to the planes of reference and all parallel. And also all projection lines are orthogonal to the projection plane, which means all the lines that are from the object go through the plane and you'll be able to view either top view or the front view on that particular quadrant. So to explain that a little bit better, I have now this complete makeshift planes reference that I made at home, but this is just to help you understand it a bit better. So this is planes reference that you have, and first of all I'm going to go through is the four quadrants. So this is your first quadrant, your second quadrant, your third quadrant, and your fourth quadrant down here. So if I was going to look at it from the first quadrant, which is your first angle, this side here is called your vertical plane, and this side is called your horizontal plane. And you're got this x line here, this black line here is your xy line, which intersects both the vertical plane and the horizontal plane. So this is your first angle projection inside this side here. And if I was going to go to the third angle projection down here, it's the same, but the vertical plane is up underneath the second quadrant and your horizontal plane is down here. So there are your four quadrants, and for first, second, third and fourth. And that's just to help you understand the plane's reference, which I'll go through later on with an object, and I'll show you the ways how, if you view an object either in the first or the third angle, what view you'll see either on the vertical plane or the horizontal plane. Here I have my object, which I made out of Lego blocks earlier. I think handing out Lego blocks to students will be very useful for them to understand how to view a 3D object in two dimensions, because they'll be able to rotate it and view each view from whatever way they're looking at it. So to take my plane's reference and put my object on my first quadrant, and if I was to look at it from this view, that's what I'll get on my front view. My front view will be above the XY line. So as you can see here, if I play with it here, it matches up, and that's what you'll see above your XY line. And if I was to look at it from the top view, that's what I'll see, and it comes out like that. And my top view will be below my XY line, like so. And if I was to take it then from the third angle projection and leave it like this, my front view will be below the XY line, as you can see. Sorry now about the writing with the Weetabix, but my front view will be like so, and my top view will be above the XY line. This is what you're going to see, and there it is on your vertical plane above the XY line. And I was talking about there earlier with the projection, parallel projection lines. That's when your object is like so. I know it's be hard for me here, but like so, all the points of your object will go parallel to the planes, which gives you your views on either your vertical plane or your horizontal plane. Finally, I'm just going to do a question for you. This object I'm going to do. I've color coded each, so just to make it easier to see each view. The top view is all green, the front view is all the blue, and the right side is all the yellow. And you can see it's in third angle projection, so if you can remember back, the front view, which will be below the XY line, and the top view will be above the XY line. if you can remember that from the planes of reference. So I'm just going to start off with the top. So remember the green. So start off drawing that. Now for the purpose of this, I'm just going to do roughly the outcome of the answer, but you will do it fully properly. As I said, this won't be perfect. So that's my top view drawn. As you can see here, this part corresponds to that, and this kind of end shape corresponds to this. So from now, what I was talking earlier from the planes of reference, I'm going to drop down my parallel projection. So basically a good few contraction lines to draw my front view. Like so, these are all your parallel projection lines. Now I'm going to draw the front view, so this is like an L shape, as you can see here, here and here. So again, so I'm just drawing in all the required views. So here you can see now the front view. So this kind of L shape, and then continue here the little box inside, which is that, and the finished part here. So they are your front two views you'll see on your planes of reference. So if you wanted to do an extra view, a right hand side view, you just again draw out your parallel projection lines, like so. This is a third view you wanted, as it's in third angle projection. Your right hand side view will be on the right side of your front view. Just going to finish off the question here now. And that's your right hand side view, which corresponds to the yellow. So this part is that, and the right part, this part here, corresponds to this side. And there's also a dashed line here because this part you cannot see, but it is part of the right hand side because it goes through, and that'll give you, that's all your right hand side. So that's for it for today, and that's all I have on orthographic projection.